Welcome to all of you, B.Sc 3 Physics students. Now, in today's lecture, we are concentrating on our chapter Crystallography, and specifically particular article is the Miller indices. So, these Miller indices plays an important role in the study of crystal structure. So, first, what is the crystallographic planes? Here I have shown one image. Here the crystal plane may be defined as imaginary plane. So this is first and foremost point is that it is just the imaginary plane or indeed any parallel plane in the crystal which intersects the main crystallographic axis of the crystal. Now this light blue colored plane intersects along x-axis at point A, along y-axis at point B, and along z-axis at point C. So I can say that A, B and C, these are the intersecting points of the planes along the three crystallographic axes. Now, what are the crystallographic notation? Crystallographic notation is the method or symbolic representation of relationship of any crystal phase to crystallographic axis. This crystallographic notation system can be explained by two methods. One is Weiss parameter and second is Miller indices. So our main concentration is on Miller indices. Now, first introductory part of the Weiss parameter. So these are the relative numbers at which given crystal phase cuts the crystallographic axis, Q, or the distance from the origin at which crystal phase intercepts the crystallographic axis. Now, the most general expression for Weiss parameter is Na as to Mb as to Pc, where N, M and P are the lengths cut off by the phase on the A, B and C axis respectively. Now, let us concentrate our mind on Miller indices. What is Miller indices? Miller indices are a symbolic representation for the orientation of plane in a crystal and are defined as the reciprocals of the fractional intercepts which the plane makes with the crystallographic axis. Most common Millerian symbol is H, K, L. So H, K, L are called as Miller indices. Now, to find the Miller indices of a plane, take the following steps. In step first, determine the intercepts of the plane along each of the three crystallographic directions. Second step, take the reciprocals of the intercepts. And third step is, if fraction results, then multiply each by the denominator of the smallest fraction. Now, see the crystallographic planes. Now, for example, this plane. So, this plane cuts the axis A, B and C along X, Y and Z. Suppose the intercepts are, suppose A equal to 1, B equal to 1 and C equal to here infinity. Why infinity? Because this plane is parallel to Z axis. Whenever the plane is parallel to any axis, then it has no interception. That means we can say infinite. So reciprocals of these intercepts are 1:1, 1:1, 1:infinity. So the answer is 1, 1, 0. So reduction 1, 1, 0, no fractions. So our Miller indices are 1, 1, 0. So read these Miller indices as 1, 1, 0 and not 110. This is the wrong. We have to read the Miller indices 1, 1, 0. Likewise, take the second example. Take this plane. Now, this plane intercepts at A equal to 1/2. So, see this intersection 1/2. B here parallel infinity and C also parallel to infinity. That means this plane is parallel to y-axis and z-axis. So, the reciprocals of these quantities are 1 upon 1/2 1 upon infinity, 1 upon infinity. So answer is 200. So no fraction. So final answer is Miller indices are 200. So this is the method how to calculate the Miller indices. Then again take one example. Now see here in this example the intercept points are along x-axis this intersection is 1, along y-axis plane is parallel, so no intercept we call infinity, along z-axis infinity, reciprocals 1 upon 1, 1 upon infinity, 1 upon infinity. So smallest ratio 1, 0, 0, Miller indices are 1, 0, 0. In second example, here likewise this plane intersects along x-axis 1, along y-axis 1, but it is parallel to z-axis. Then the intercepts are 1, 1, infinity. Reciprocals are 1 upon 1, 1 upon 1, 1 upon infinity. So the smallest ratio is 1, 1, 0. The Miller indices of this plane are 1, 1, 0. Now, this is a very good example of the plane intercepting at equidistant to each and every crystallographic axis. So intercept points are 1, 1, 1. Of course, reciprocals are 1, 1, 1. So the Miller indices are 1, 1, 1. Then in this figure, this plane intercepts along x-axis at 1/2, along y-axis as 1, and it is parallel to z-axis, so it is infinity. Reciprocals are 1 upon 1/2, 1 upon 1, 1 upon 1. So the smallest ratio is 2, 1, 0. Miller indices are 2, 1, 0. So we can say that the Miller indices are very simple to calculate. So what is the comparison between B.Sc and Miller indices? B.Sc indices are the just intercepts on the 3 coordinate axis. On the other hand, Miller indices are the reciprocals of the intercepts made by the plane on 3 coordinate axis. Now, if the plane is parallel to any of the 3 axes, the intercepts made by the plane is denoted by infinity. If the plane is parallel to any of the 3 axes, the Miller indices for the plane is 0. If the y0 because it is reciprocal. So reciprocal of infinity is answer 0. If the plane intersects the axis on negative axis, then the intercept is also negative. But in Miller indices, if the plane intercepts on the negative axis, then the Miller indices is denoted by bar on the top of the digit, over the digit. So these B.Sc indices are not convenient. On the other hand, Miller indices are more convenient, and we are using throughout the Miller indices to study the crystal structure. Now, see here the crystal forms. Actually, a crystal form is a set of crystal faces that are related to each other by symmetry. See, these figures indicates that the different forms of the crystals. So very interesting forms of the crystals: pyramid, then octahedral, cube, and prism, and biprism, and this parallelepiped, etc. So the types of the crystal forms. So basically, crystal forms are broadly classified into 2 types. One is closed form, and second one is open form. So in all there are 48 possible forms. Those are mainly classified as in 1 common form non-isometric system in all 38, and in common form in isometric system in 10. So this is about the how to calculate Miller indices, how the Miller indices are very useful to study the crystal structure. So this is about the crystallography in the chapter 1st. Okay.